Can you hear me?
Hello?
Hello.
Yeah,
You can hear me, right?
yeah.
We have to do one last topic in the chapter, multinomial theorem. But do you have any other doubts, any problems, anything?
We had a discussion, like we had a class for the doubt discussion, so I got them honestly, the mains problems. And then it was
Okay, so there no nothing left in 4B or anything, right?
no, no.
And they have started doing PNC.
Yeah, they started.
So next class will for us will be about PNC and all. We'll start that chapter.
Okay.
Uh, have they discussed this topic, multinomial theorem?
Yes, they have. No proof, but they have given up on the
Have you understood what is happening?
um
What is this theorem about?
60% of it.
Hmm. Okay, so basically the idea is binomial theorem was when we expand it like this and it was a binomial, two terms, right? And we said this was a binomial, two terms. And we know how to expand it. We know that it is r is equal to 0 to n, ncr, x power n minus r, and a power r, right? Correct.
Yes.
Now, if suppose we had, uh, let's say, more than two terms. But before that, I will just write this in a different way. I'll write it as r is equal to 0 n factorial by n minus r factorial, x power n minus r, and a power r. And now, if I have more than two terms, suppose I have x1 plus x2 plus x3 power n. I have to do this expansion. Then this becomes what we call a multinomial. It's not just two terms, it's more than two terms, right? So how do we write the expansion for this? So briefly, we had discussed in the last class that in one of the classes before that we can take this in terms of two groups of two and all, right? Two and one.
Yes.
So we can think of it like this, that this is the first term x1 plus x2 and this is the second term. So we could have written it like this, summation r is equal to 0 to n ncr, and we can do x1 plus x2 to the power n minus r and x3 power r, right?
Yes.
Basically, we are doing the same thing as binomial theorem, except my first term is not x1, it is x1 plus x2,
Yeah.
right? And then you would have to expand this also, correct?
Yeah.
Because in general, this will have some expansion.
Yeah.
So if you think about it, uh, I will try and expand it, but first I'll write the outer summation r is 0 to n and ncr x3 power r I have kept like this, and then I'll expand this part. So this part is power n minus r. So my summation will be, let's say, k goes from 0 to n minus r, right?
Yes.
Because the power is n minus r, here power was n, so summation was till n.
Right.
And now variable of summation I've changed because r has already been used, so I'll use k now.
Right.
And it will be x1. No, first there will be an ncr type of term. So it will be n minus rck, right?
Right.
And it will be x1 power this minus this, n minus r minus k, multiplied by x2 power k, right?
Right.
So this type of thing is coming. So that is what you get when you do this. Now, if you combine everything, what you are getting is summation of r goes from 0 to n and summation of k goes from 0 to n minus r. You have ncr and n minus r ck, x3 power r, x1 power n minus r minus k, and x2 power k, right?
Yeah.
So notice that the powers here on top are adding up to n, right?
Yes.
And if you multiply these two combinations, you will get n factorial by r factorial n minus r factorial multiplied by n minus r factorial by k factorial and n minus r minus k factorial.
Right.
So this will cancel, this will cancel, and you will be left with n factorial by r factorial k factorial n minus r minus k factorial, right?
Right.
So the multiplication of these two gives us this, and notice that the powers of the variables are also that only k, r, n minus r minus k, right?
Right.
So ultimately, the terms of this binomial expansion become something like this. Multinomial expansion becomes something like this: x1 plus x2 plus x3 power n is going to be terms like this, where you have n factorial by r factorial k factorial s factorial, x1 power r, x2 power s, x3 power k, where r plus s plus k will add up to n. Terms like this, where this is overall r s k. Everything in r s k could vary.
Right.
Basically, you are going to get many terms. All the terms which is possible, which will add up to n, right? All
Yeah.
combinations. So you could have a term which has just 0, 0 and n, right? So
Yeah.
that will end up giving you the term x1 power 0, x2 power 0, and x3 power n, right?
Yeah.
Basically, you could have one term in this expansion which is x3 power n, right? You could have x1 power n also, you could have x2 power n also, but you will also have terms like x1, x2, x3 power n minus 2.
Yes.
So technically what we are doing is similar to binomial theorem. Uh, in binomial theorem, all the terms powers added up to n, right?
Yeah.
Here also all the terms powers add up to n. It's just that they have more than two terms. And
Right.
the coefficients are obtained like this. The coefficients are obtained like this. You first write the general term. General term will have general powers some r s k, and you just write the coefficient by doing n factorial by r factorial s factorial k factorial, and r s k have to be chosen such that r plus s plus k should be equal to n always, right?
Yeah.
And in the next chapter we will learn how many different solutions are there to this equation, like how many solutions are possible to this equation, or in how many different ways can you add r plus s plus k and give n.
Yeah.
So once we learn that, then we will be able to say how many such terms will be there, right?
Yeah.
So in that case, for now, here I will just tell you the answer. Here it will be there are three different variables which have to add up to n. In that case, the answer will be n plus 2c2. Okay. So
Yeah.
we will learn the explanation of that in the next chapter. So suppose there was 4, right? Or suppose there are r terms like this: x1 plus x2 plus x3. There are r different terms which have to add up to n, right?
Yeah.
Then the answer would be n plus r minus 1 c r minus 1. Okay.
Yeah.
So there will be that many different terms. Okay. There
Yeah.
will be at that many different terms. So because in that many ways you could get x1 plus x2 adding up to n. So that many different terms will be there. And each term you can write. So for example, let's take an example how to write the general thing. So let's say we have x1 plus x2 plus x3 plus x4 and we have to do whole power 7, right? In this
Yeah.
case, what I will say is general term, I will just write like this 7 factorial by r s k t, and it will be x1 power r, x2 power s, x3 power k, x4 power t. This is my general term where r plus s plus k plus t has to be equal to 7.
Right.
Okay. So the powers have to add up to 7, and you can have this in many different combinations, right? This
Yeah.
these can be equal to 7 in many different ways,
Yes.
starting from zero values and all.
Yeah.
So how many ways are there? So for that you need to remember that whenever we have x1 plus x2 plus xk equal to n, and there are k variables here and zeros are allowed, it can be 0. 0 is allowed.
Right.
Then the number of answers for this equation is n plus k minus 1 ck minus 1. Okay.
Right.
Yes, we will. So right now,
I can't hear you. Your voice is breaking a lot.
can you hear me right now?
Yeah, I can now.
1 second. Right now, am I audible?
Yeah.
Okay. So in this case, if you think about it, what happens is n is 7, right? And there are 4 variables, right? We have
Yes.
x1 plus x2 plus x3 plus x4, 4 variables, and n is 7. So how many
Yeah.
ways can that happen? That will happen in 7
7 C.
plus 4 minus 1, c4 minus 1. It will be 10 c3. Okay.
Yeah.
So basically 10 factorial by 7 factorial, 3 factorial, that becomes 10 into 9 into 8 by 6. So this is basically 72 by 6 or 12, and this is 120, right?
Right.
So technically there are 120 different ways in which you could have this. So there are 120 terms total in this multinomial expansion.
Yeah.
Many of the terms will become alike eventually, may become alike, but uh, in general you could have that many terms. You could have starting with say this 0, this 0, this 0, this 7, and you can keep listing down the different ways, right?
Yeah.
So there will be many such terms, 120 of them, and this is the general term of the multinomial series. Okay.
Yeah.
So now, uh, if you have these common cases, typical cases, let's say most common cases will be x plus y plus z to the power n. Let's say we have x plus y plus z to the power n. The general such that r plus s plus t equal to n, and it will be n factorial by r factorial s factorial t factorial x power r y power s z power t. That is your general term of this series, right?
Right.
And how many terms will be there? There will be n plus 2c2 terms. because
Yes.
total has to be n and there are three variables. So you'll
Yeah.
use the formula n plus r minus 1 c r minus 1, right?
Yeah.
Similarly, common example is when you have four variables like this and to the power n, then the general term is n factorial by r factorial, s factorial, t factorial, and maybe let's say p factorial. It will be x power r, y power s, z power t, and w power p, such that the addition of these four is equal to n. How many terms will be there? It will be n plus 3 c3.
Yes.
That many terms will come.
Yeah.
Okay. So in general, that is your theory for multinomial theorem. You will not have too many questions using that, but sometimes you might need it. So you just need to know it.
Yeah.
Then we have certain types of questions that you might have seen, maybe one or two questions in your uh, exercise where we have to use applications of binomial theorem in a certain way. So we'll do these questions, a few of them. So question one is, for example, show that show that 7 power 2n plus 7 power 2n plus 7 is divisible by 8. Is divisible by 8. Okay, where n is a positive integer. So how will you prove that? That is the question. Basically, we have to somehow show that this is equal to 8k or something, right?
Yeah.
If I have to show that this is 8 divisible by 8, I have to try to use 8 somehow in this. So what I will say is 7 is equal to 8 minus 1, right?
Yeah.
And I will say that this expansion can be written as 8 minus 1 power 2n plus 7, right?
Yeah.
If I do binomial theorem on this, what kind of terms will I get? We'll start with 2n c0 and it will be 8 power 2n, right? And then 2n c1, 8 power 2n minus 1 and minus 1 power 1, right?
Yeah.
And so on, so on. I will go on till 2n c2n and it will be 8 power 0 and minus 1 power 2n, right?
Yes.
And then there will be a plus 7, correct?
Yeah.
So notice that every term from here till here and the term before this has 8 power 1, right? Any
Yeah.
term before this, any term till here
Yeah.
has 8 power 1 at least, or 8 power 2, or higher
Yes.
powers of 8. So those parts are anyway divisible by 8.
Yeah.
So we only have to worry about this term and this term.
Right.
So if you see this is just 1, right?
Yes.
Plus 1. Because 2n c2n is 1 and this is 1. So it's plus 1 plus 7, right?
Yeah.
So you're getting something divisible by 8, divisible by 8 plus 1 plus 7, which is 8.
Yeah.
So the overall thing becomes divisible by 8, right?
Yeah.
So the idea is pretty simple. Like these are applications where you need to use like other portions of maths also, but ultimately somewhere you have to use binomial theorem to get the thing.
Yes.
So we are showing divisibility by 7 using the expansion of 7 as 8 minus 1.
Right.
Okay. The next one is Similar type of question, but slightly more difficult this time. It is prove that, say, 13 power 99, 13 power 99 minus 19 power 57. 13 power 99 minus 19 power 57 is divisible by 162. Is divisible by 162. So here you have to be a little more careful. In order to prove divisibility by 162, you have to basically show that this expression is equal to 162k, something like this, right?
Yeah.
And 162 is actually 2 times 81. So you have to take out somehow common 2 into 3 power 4, right?
Yes.
So whatever will be the expansion of this, you should be able to take this thing common out of it, right? Then only it
Yeah.
will become 162 times k.
Yes.
So now you have to think about how you would go about expanding this. So what you can do is 13 can be written as 1 plus 12 and 19 can be written as 1 plus 18. Why are we writing it like this? Because the expansion of 1 plus x power n is easier to write.
Yeah.
Okay. So you have 1 plus this power 99 and this power 57, like this. And this is basically 1 plus 3 into 2 square power 99, right?
Yeah.
And this is 1 plus 2 into 3 square power 57, correct?
Yeah.
And then we have to actually subtract the two series, right? Correct.
Yes.
So whatever be the expansions, we have to do subtraction here. So let's write the top expansion. It becomes series 1 is equal to 1 plus 99 C1 into it will be 3 into 2 square, right? And
Yeah.
plus 99 C2 into 3 into 2 square whole square.
Yeah.
And so on, terms will go on till 99 C99 3 into 2 square power 99,
Yeah.
right? And S2 terms will be 1 plus 57 C1 and 2 into 3 square and 57 C2 2 into 3 square whole square and so on till
Yes.
57 C57 2 into 3 square power 57. Now when we do the subtraction, we have to keep in mind our target. Our target is to be able to take this part common. We have to
Yeah.
prove divisibility by 162, which is 2 into 3 power 4, right?
Yeah.
So think about it. Whenever you subtract and you get s finally, this terms will cancel. You'll have this minus this, and further terms, right?
Yeah.
So further terms, if you think about, it will have powers of 3, 3 power 3 and 2 power, it will be at least 2 power 2 whole power 3, right? So it will be 2 power 6, right? At least.
Yeah.
Here the powers will become 3 power 3, 2 power 6. Here the
Yeah.
powers will become 2 power 3, 3 power 6, right?
Yeah.
So when the powers are higher, you will always be able to take this much common, right?
Yeah.
When you have a subtraction of something multiplied by this and all, you can take this common, right?
Yes.
Because powers are greater than 4 for 3
Yeah.
and 1 for 2, right?
Yeah.
So you can think about it and you will realize that after this point, you can always take 162 common. after subtracting also, right?
Yeah.
Are you understanding what I'm saying?
Yes.
In the final series, this minus this, I can take 162 common in this term, 162 common in this term, in
Yeah.
this term and all. So everything after this is divisible by 162.
Yeah.
Before this, it's not sure. We can't take common all the time here, right?
Right.
So we have to work through it and see if it is coming or not. So this is 99C1, which is 99. So 99 into 3 into 2 square minus 57 into 2 into 3 square. That is the first term, right?
Yeah.
And notice that here it is 3 power 2, 2 power 4, and here it is 2 power 2, 3 power 4, right?
Yeah.
So here immediately it doesn't seem like we can take 3 power 4 common because 3 power 4 is here but it's not here yet, right?
Yeah.
But if you work through it a little bit, because of the presence of 99C2, we might be able to do it, right?
Yeah.
So if you think about 99C2, it is 99 into 98 by 2, right? So multiplied by 3 square 2 power 4 minus this side is 57 into 56 by 2 multiplied by 2 square 3 power 4, right?
Yeah.
This is the second term, and 99 is divisible by 9, so it already has a 3 square in it, right?
Yeah.
So you can say it is 11 times 98 into 3 power 4 2 power 4, right?
Yeah.
And 2 can be used in 49, minus here you get 28 into 57 into 2 square 3 4, right?
Yeah.
So clearly 2 into 3 power 4 can be taken common from this and from this, right?
Yeah.
Are you understanding what I'm saying?
Yes.
So even this term you can take 162 common,
Yeah.
right? So now all that is left is to check whether this term is divisible by 162 or not, the first term.
Right.
So here, if you see, we have 2 square here and 3 power 1, but 99 is again 3 square is there anyway, right?
Yeah.
So we can say it is 11 into 3 power 3 2 power 2 minus this is 57 into this. So we can say this is 3 into 19. So 19 into 2 into 3 power 3, right?
Yeah.
This is 19 into 2 into 3 power 3. This is 11 into 2 square into 3 power 3, right?
57 is 19 times 3, right?
Yeah. So
Yeah.
19 into 3, that's why it
Yeah. Yeah.
became
Yeah.
3
Correct.
power.
Correct.
So you can take 2 into 3 power 3 common because that is there in both, and it will become 22 minus this will become 19, right?
19. Yes.
And that is basically 3. So that will become 2 into 3 power 4, right?
Yeah.
So this difference is actually 162, and other
Yeah.
differences are 162 is definitely coming common.
Yeah.
So it is divisible by 162 because this is coming 162 plus something into 162, right? Something like this is coming, right?
Yes.
So that is an example of another question. This was actually asked in JEE Advanced. This was an example of how you use binomial theorem to prove things. Otherwise, it is impossible to do this otherwise. Like without binomial theorem, it will be difficult to do, right? Because we
Yeah.
have no idea what these numbers are, correct?
Yeah.
Again, sometimes they might ask you things like find the remainder, find the remainder when, let's say, 5 power 2015 is divided by 13. Questions like this. 5 power 2015 is divided by 13. Find the remainder. Okay. So what is happening here? Like, how would you even think about it? You will say that, okay, when I divide some number by another number or quotient,
Yeah.
then I should get a dividend. No, when I divide a dividend by a divisor, I should get a quotient and a remainder, right?
Yes.
So I will say 5 to the power 2015 should be equal to 13 times quotient plus some remainder, right?
Yes.
And we have to find out the value of the remainder, r, right?
Right.
So how would we go about getting this r? So ideally, I would like to express this side in terms of things which are 13 or related to 13, right?
Yeah.
Then only I can get what is not divisible by 13, right?
Yeah.
So, okay, so it is 5 power 2015. So 5 square is 25 and 25 can be written as 26 minus 1, right?
Yeah. Yeah.
So I will be able to expand 26 minus 1 by binomial theorem and I will get terms that will be divisible by 13 then, right?
Yeah.
So that is my main idea now. So 5 power 2015 I can write as 5 power 1 into 5 power 2014. 5 power 2014 and 5 power 2014 I will write as 5 square into 1007, right?
Yes.
And this is 25, so this is 26 minus 1 to the power 1007,
Yeah.
right? So this series will have many terms. It will start off with 26 power 1007 and then it will be 1007 C1 26 power 1006 into minus 1 power 1 and so on, right?
Yeah.
And then one term will be at towards the end, it will be 1007 C 1006 and it will be 26 power 1 and minus 1 power 1006, right?
Right.
And last term will be 1007 C 1007 and it will be 26 power 0 and minus 1 power 1007, right?
Yeah. Yes.
So if you notice, all the terms up to this term are divisible by 26, right?
Yes.
Till here. Only this last term is the one that is not divisible, right?
Yeah.
So you can clearly write this as some 26 times k and this last term is minus 1, right?
Yes.
This last term is minus 1. The
Yeah.
every term before that is 26 into something because you can
Yeah.
take 26 common. So 5 power 2014 is becoming some 26k minus 1, right?
Yeah.
So our 5 power 2015 is 5 times that. So you'll do 5 times 26k minus 1. You will get some 130k minus 5, right?
Yes.
So this part is divisible by 13, but you are getting minus 5. So we can write it as uh, it will be 129k plus 8, right?
Yes.
Like when something is less, we can say, uh, for example, the number 21, for example, can be written
Yeah.
as 13 into 1 plus 2, or it can be written as 13 into 1 plus 8 or 13 into 2 minus 5, right?
Yeah.
It can give remainder of plus 8 or minus 5.
Yes.
So that is what I'm saying. If it is 130k minus 5, it can be written as 129k plus 8
Oh, yes.
because it is above 129k but below 130k,
Yeah.
right?
Yeah.
So the remainder not 129k. The remainder, this part is divisible by 13, remainder is -5. So minus
Yeah.
5 remainder is equivalent to 8 remainder, right?
Yeah.
I don't know which integer will come, but I know 8 will be the remainder, because when you think of remainders, negative remainder means it's 5 less than the next multiple of 13, right?
Yes.
So that will be, answer will be 8 then. Are you understanding what is happening?
Yeah.
Main thing to understand is how to use binomial theorem to do this. So we wanted it to come in terms of 13 and stuff, this expansion somehow.
Yeah. Yeah.
So therefore we saw, okay, 13, how will I relate 13 to 5? So I will take the squares and all of 5. 25 is close to 26. So that's why that works. 26 minus 1, right? And then we
Yeah.
wrote 5 square is 26 minus 1 and expanded 5 square and all. And then that's easy after that.
Right.
Uh, Another type of question that you might see is find the last 2 digits of something. Find the last 2 digits or last 3 digits of some random number they will give you. In JEE mains also this has been asked sometimes. So for example, the question was find the last 3 digits of 13, last 3 digits of 13 power 256. So technically, whenever they'll ask you last 2 digits or last 3 digits, what they want is what is the remainder when you divide it by 100 or 1000 or whatever, right? So if you have 234, last 2 digits are 34. How do you get it? If you divide it by 100, remainder is 34,
Oh, right.
right?
Yeah.
If I have some number 1057, what are the last 3 digits? It is 57.
Yeah.
It is the remainder that you get if you divide it by 1000.
Yes.
So it is obvious, it's the same question as before. The question is asked in a different way, but
Right.
technically what they are asking is remainder when you divide it by 1000. When you divide 13 power 256 by 1000, right?
Yeah.
Okay, so now we have to somehow get the remainder when we divide it by 1000. So if you think of 13, 13 square is 169, and
Yeah.
169 can be written as 170 minus 1,
Yes.
right? Why will we use this? Because as soon as you get 170, when you raise the powers, since there is a zero at the end, it will cause many hundreds and all to come, right?
Yes.
Hundreds, thousands and all.
Yeah.
It will be easy to decide, okay, which one is divisible by 1000 once we expand this, right?
Yeah.
So 13 power 256 can be written as 13 square power 128, and that is 169 power 128, and that is 170 minus 1 power 128, right?
Yeah.
So you will end up initially getting many higher powers here, 170 power 128 minus 128 C1, 170 power 127 into 1, and so on. The initial powers don't concern us because they have so many zeros, right?
Yeah.
When 170 power 128, you'll have some, it is 10 power 128 into 17 power
Yeah.
128, right? So those ones are not a problem. Those ones anyway have too many zeros. We have to look at the last 2, 3 terms, right?
Yeah.
Because the last 2, 3 terms will be the ones which have fewer zeros, right?
Yeah.
So it will be, let's say, minus 128 C 125 will have 170 power 3 and 1, right? And then plus 128 C 126 will have 170 power 2, right? And
Yeah.
these are the last 3, 4 terms that I'm writing. Okay. And the last term will be plus 128c 128 1 minus 1 power 128 is 1, right? I have
Yeah.
written the last four terms here. You can see that in this term, this is divisible by 1000, right? 0 power 10 power 3 is coming, right?
Yeah.
So every term before this is divisible by 1000, and even this
Yeah.
has 1000. So we need to worry only about these, right?
Right.
So basically, 1000, everything else can be written as 1000 times k plus these three terms, right?
Right.
So that will be the remainder. If you find the value of these three terms, that will be my remainder when I divide by 1000, right?
Yeah.
So this term is 128 into 127 by 2 into, this is 170 square. Okay, and minus we have 128 into 170, and we have plus 1. So let's see what we can do here. If we take 128 into 170 common in the first two, get 128 into 170 common, and we get 127 into 170 by 2 minus 1, right? And plus 1.
Yes.
So you're getting something very big here. So we have to still divide it by 1000 to see what remainder comes, because this is the original series. We have to still divide it by 1000, I think, right?
Yeah.
No, because the number is coming very big.
Yeah.
This number is coming very big, so we are getting everything before that was divisible by 1000, but this number still is a very big number, right?
Right.
So technically at this stage there is nothing you can do. You have to multiply it out and get the number. At this stage you have done whatever you can to make the problem easier. You have to multiply it, these three terms and all, and figure out what is the answer. It turns out that the answer is, in this case, after multiplying, 2348, some very big number, 23487741, something like this. So
And we have to actually multiply this.
it's four multiplications, only four, no?
Okay.
I mean, you have to do it if it is coming.
Yeah, yeah.
441 is the remainder, because when you add something which is divisible by 1000, only this last three terms will come out there.
Yeah.
441 will be the answer, last three digits of this. Are you understanding what is the general process?
Yes.
Okay. That's all for this chapter. There's nothing else much here.
Yeah.
You can try this question. Try this question at home. This is on multinomial theorem. In the expansion of 1 plus x plus 5 by x whole to the power 11. Find the term independent of x. This has been asked in JEE Advanced. You have to find the term independent of x. There will obviously be many terms might happen which will be independent of x. You'll have to think about how you would get an independent of x term, right?
Right.
Ideally, it will be like the general term of this series is 11 factorial by some r factorial, s factorial, t factorial, and it will be 1 power r, x power s, and 5 by x power t such that r plus s plus t is equal to 11.
Yeah.
And if you want term independent of x, you will have s and t should match, right?
Right.
You also have additional condition s is equal to t.
Okay.
So there will be many possible ways to do that. So basically, technically, the solution is r plus 2s equal to 11, right? There will be many ways to do it. S is equal to t is happening, therefore we can write r plus 2s is 11, right?
Right.
So an r and s are integers, so you can't have r0 because then 2s is equal to 11 makes no sense. So you have to start with r1 and 2s will be 5 then, right?
Yeah.
All the odd numbers for r you have to check, right? R can be 1, 3, 5, 7, 9, 11, right? And in those cases,
Yeah.
s values will come 5, and then you'll get 4, right?
Yeah.
3, 2, 1, 0, right?
Yeah.
Basically, these 6 different terms will come. You understand what I'm doing?
Yes.
Each term you can calculate now, right? 11 factorial by r and s and t are same, r and s values
Yeah.
are coming, so you'll get the
Yeah.
terms. So
Yeah.
all of those terms will be independent of x because the x powers are cancelling there.
Right.
So such questions are common. So you need to be able to write the general term and think yourself how to handle it after that.
Right.
There will be many terms, but we have a special condition, right?
Yeah.
Okay, that's all for this chapter. We'll start PNC in the next class. Next class will probably be on Thursday.
Yeah.
Okay.
Yeah. Bye.
Bye.